Good evening, everybody. This is Dr. Arunava Majumder, the Assistant Professor of lovely Professional University, and this is my second lecture of Engineering Mathematics, the important question and answer. And this is as we have already started our first lecture, which is introductory lecture of Engineering Professor of lovely Professional University. And there I have shown you this is my second lecture applications of Engineering Mathematics. Applications of matrix and answer, the applications of this is as we have all started the topics of linear algebra, introductory applications of calculus, engineering differential equation, and there I have many. This is my second lecture. Application today's lecture we are going to learn about the operations on matrices of this is very important topic of linear algebra, introductory applications of calculus, applications of differential equation, and there and many is a very important. That is today's lecture very important goal are going to learn about the already give you an example of this is very important image processing of algebra, how many applications pixel of an image and there represented by is a very important. That is today's lecture very important goal are just change the values of the matrix already and give you an example by different change the value of image processing by different operations. Then how we can also change the pixel of the also represented by the image and also that is today's lecture we can also change the values of the color of the image and so by different change the values of image by different operations. First how we can also change the pixel of the also representation of the image what for how and we represent also change the values of the color of the image already you by different ideas change the values in by different operations. First and how we can also change the pixel of the just going to definition what for example and how represent also change the values of the color of the image already can be presented by ideas using the values in this is an array. First and basically we can array of the pixel and this array actually we represent a matrix by using row and column. Like can we represent it by first drawing an array here? This is an array actually, and basically it's represented 5 6 and this array actually we represent a matrix by using, so you can see each and every element of this matrix is represented by a particular row and an array. Actually, in this particular matrix, we have three rows, and this is row one, row two. We represent a matrix by row two. So, and it's three different columns. Each and every element of this matrix is represented by a particular row and an array. Now, in this first element, we have these three elements of the matrix. This is one. This element can be represented as and row one and column each and every intersection point of row one and a particular row and column one. Now, what is the intersection point? First element is these three elements of the matrix. This is one, and so we can say element in this matrix can be as and row one if I each and every just intersection point of matrix like this A11 column A1. Now, what is the intersection point? First element is just the first row and denoting it like this one, and look at this A1. We can say element in this matrix row one can be and row one if I R1 and C just intersection this element is matrix like this. In general, A1 first row and first is the first element is presented as A1. This is just like this one, and look at this A1 value of A1 in this matrix A1 can be and row one if I accordingly this this element is matrix like this. Similarly, A1 can see here A1 is the this is row one presented as A1 column just like this. Now, what is the value of A1 value of A1 is the A1 can be and row one if I and similarly A13 this element is matrix like this. A1 can see here A1 row one this is and column one presented as A1 column one. Now, what is the value of A1 can be A1 the A1 is 2 and row one if I and similarly A13 this element is matrix. Now, look at the A1 can see here this matrix row one this matrix column one these elements column one. Now, what are called the diagonal elements? That is, if I rewrite this matrix like this, A1 and similarly A1 2 this element is matrix. Now, look at the A1 this matrix row one this matrix column one these elements column one and A. Now, what are called the diagonal elements? Now, look at this. That is, every diagonal element this matrix like this A1 and A11 A1 2 A now look at that these three elements called diagonal element. A11 for this matrix called the diagonal element. Now, look at this. For this particular diagonal element this matrix A22 what is the value? 5 is the value. A is equal to 5 and similarly A33 these three elements called 9 is the value. This is A11 for this matrix called the diagonal element. So this is the for this particular diagonal element that is this is how A22 what is the value? 5 is the value. Using this is equal to 5 columns and similarly in general these three elements. So this matrix you look at this how many rows are there? Rows number of rows are 3 the number of columns this particular diagonal. So if the number of rows is 5 is equal to the number of columns and similarly in general these three elements then with this matrix you look at this how many rows are there? Rows number of rows are 3 the number of columns this particular diagonal. So if the number of rows is the value of 5 is equal to the number of row and number of columns in general equal to then with this matrix you look at what is non-square matrix there. Non-square matrix if the number of rows are 3 the number of columns is not diagonal. So just like the number of say A11 is equal to 1 number of columns and up to it is A1 then with this matrix what is non-square matrix n number of columns if the number of columns 1 column 2 not diagonal. So just like the number of say n numbers of columns are there what A11. Similarly for the second row it will be A21 A22 and so on. And what is the last element? The last element, of course, it will be, you can see it is nth column. Okay, and second row, so it is a to n, and so on. So these all elements will be written like this. And the last row, let us suppose the number of row, this is row 1, this is row 2, and the last row, let us suppose it is m number of rows are there. You can see here in this particular matrix, m and n, they are different. It means number of rows and number of columns are different. Okay, so last row, it can be represented as, so you can see it is mth row and first column. The second element will be mth row and second column, sorry, mth row and second column. And the, what will be the last element? It is a mth row nth column. So this will be the general form of a matrix with m cross n, that is, this is the dimension of the matrix, it is called. Okay, so a, if I say this matrix, m number of rows and n number of columns. Okay, in general, mathematically, we represent any matrix like a m cross n. It means that a is a matrix. Let us suppose this is the matrix a, and what is the row and column? Row is m and column is n. So n cross n, this will be the dimension of the matrix. Okay, next I am giving you an example how a matrix operation, that is how a matrix can be formed. Okay, so you can see here, these are three persons: person a, person b, sorry, person a, person b, and person c. These three persons are going to a supermarket. This is a supermarket. These three persons are going to purchase something. Okay, these three persons are going to supermarket. Okay, a, b, and c, and let us suppose they are going to purchase something. And let us suppose that they are going to purchase some rice and some sugars. Okay, so person a, okay, person a, let us suppose a buys 5 kilograms of rice, 5 kg of rice, and also she is purchasing 3 kilograms of sugar, 3 kg of sugar. Okay, and the payment, what she pays? She pays 440 rupees to the supermarket. Okay, she pays 440 rupees to the supermarket. Okay, by purchasing 5 kilograms of rice and 3 kilograms of sugar. And similarly, the person B, she purchased 6 kilograms of rice and let us suppose 2 kilograms of sugar. And what she there is the payment, what is what the payment she made? She made the payment of rupees 400. Just let us suppose. Okay, and person C, there is she purchased, let us suppose, 8 kilograms of rice. Okay, and 5 kilograms of sugar, and made a payment of rupees uh, 720. Okay, now we can formulate a mathematical model from this particular, that is this particular model. Okay, there is means this particular example, this is a real life example. These three persons, a, b, and c, went to a supermarket and purchased these amounts of sugar and rice, and the payments what they made. So all these data are given to you. Okay, now we need to make a mathematical model, okay, to identify, that is to find out how much, okay, that is there is already 3 kilograms, and so this is, so we need to formulate a mathematical model to compute the price per kilogram of rice and the price per kilogram of sugar. That is how much amount that is a person needs to pay, okay, per kilogram of rice and per kilogram of sugar. That is what is the price of rice and what is the price of sugar, basically. This is the question. Okay, so my question is, what is the price price of rice per kg and price of sugar per kg? Okay, so this is the question. Now how can you solve it? So first we need to form a mathematical model. Okay, and which is also this kind of mathematical model, I think some of you have already have done in the means lower classes, but I in the ninth or 10th level. So this kind of problem, but this is quite a big problem. That is, the problems are there is a large problem, and here we can formulate three different equations. How? Let us suppose, okay, let us suppose the price, okay, price of rice per kg, rice per kg is equal to x, that is x rupees, and the price of sugar per kg is equal to y. Let us suppose, just, okay. Now the question is, now for person A, now let us suppose for person A, how much kilogram of rice person A purchased? 5 kilograms. Okay, price of rice per kg is x rupees. So how much she paid for 5 kilograms of rice? Of course it is 5 into x. Okay, and 3 kilograms of sugar. So the sugar price per kilogram is y, and person A purchased 3 kilograms of sugar. So of course 3 into y. This is the price of sugar person A paid. Now if I add these two amounts, of course it will be equal to 440 rupees, which is the total amount paid by the person A. So this is equation number 1, let us suppose. Okay, now the second equation is can be formed from person B. So 6 kilogram of rice, it means 6 into x, and plus she purchased 2 kilograms of sugar, so 2 into y, and this is equal to 400. Of course, because the person B have paid 400 rupees to the supermarket, and this is equation number 2. And from person C, 8 kilogram of rice, so 8 kilogram of rice means 8 into x, plus 5 kilograms of sugar, so 5 into y, and of course it will be equal to the 720, because C have paid 720 rupees to the supermarket. So these three equations we have got. Okay, now how can we formulate it? Now these three, now by using, if I can solve these three equations, then we can easily find what is the per unit price of rice and per unit price of the sugar. Per unit means per kilogram price of rice and per kilogram price of the sugar, we can easily identify after solving these three equations. But how can we solve it? Okay, you, if you remember in lower classes, in the 10th or 11th level, we can solve two equations by using different methods. But here three equations, and how many variables are there? Two variables, x and y. Okay, now here to solve it we need to form a matrix. It will be better to form a matrix and system of linear equation matrix to solve this kind of problem. So we can model. So this is the model. Actually these three equations, these three equations, it forms a mathematical model. Okay, so now let us erase this part. Okay, now I am going to show you how these three equations can be represented by a matrix form. So you can see this part, the left hand side part, each and every equations, the left hand side part, I am writing a matrix form like this. The first row 5 3 6 2 8 5. Okay, and this is the matrix. And then, okay, so this is the matrix here. Okay, and then you can see there is another, how many variables are there? Two variables. And the right hand side I am writing it like this, another matrix, which is 440, 400 and 720. Okay, now I think you all know how matrix can be multiplied. Okay, so you can see if I multiply these two matrices, that is this one and this one, what we get? Look at the first row, 5 into x and 3 into y. You can see 5 into x plus 3 into y. This is of course equal to 440. Similarly, 6 into x plus 2 into y. So 6 into x plus 2 into y. This is of course equal to 400. So 400. And similarly, 8 into x plus 5 into y. This is of course equal to 720. Okay, so we can form a matrix. Okay, by using this system of linear equations, and after forming this matrix we can, our solution process will be easier here, much more easier. Okay, so I will means give you how to solve this matrix form, that is how to solve this one, this matrix form. Okay, and how can you find out the values of x and y? I will come to this part later, but now only we are I'm giving you the idea of matrix and how the matrix is formed, and what are the real life examples. Okay, okay, now I am going to show you some applications, that is means matrix addition and matrix multiplication. Okay, these kinds of things. I think everybody you know this, but still, I'm just going to give you a little bit example of addition and multiplication. You can see matrix addition or subtraction. It is very easy. Let us suppose A is equal to 1 3 5 2 and B is equal to 1 5 2 1. Okay, now A plus B. What is A plus B? Simply we add the elements to element, that is this element, the first row A11 element will be added to the A11 element of B matrix, that is 1 plus 1 2. Similarly, A21 element and A21 element of B matrix will be added, 8. 5 plus 3 8. Similarly, this and this, 5 plus 2 7, and this 2 plus 1 3. Matrix addition, and similarly matrix subtraction will be also exactly like this. Okay, 1 minus 1 it is 0. Okay, 3 minus 5 it is minus 2, and 5 minus 2, 3. Okay, 2 minus 1, it is 1. So this is simply matrix addition. Now what is matrix multiplication? Same. Okay, A cross B. If I multiply these two matrices, 1 3, 5 2, 1 5 2 1. So now you see matrix multiplication. There is a condition of matrix multiplication. Okay, that is the number of column of the first matrix. This is A matrix. How many columns are there? 1 2. Two columns are there, C1 and C2. Will must be equal to the number of rows. This is R1 and R2. Okay, number of rows of B matrix. That is, number of column of A matrix must be equal to the number of rows of the second matrix. Then the matrix multiplication is possible, otherwise it is not possible. Okay, now how to multiply? First we multiply these two elements with these two elements and add together. It means this one will be multiplied with this one, so 1 into 1, and then this element will be multiplied with this 2, so 3 into 2 plus 3 into 2. This will be the, this element will be the first element of this matrix. Okay, exactly in the similar manner we will do the same thing for the, okay, let us, okay, now for this element a2 a1 2 element, these two elements will be multiplied with these two elements, that is 1 into 5 plus 3 into 1. Okay, now what is the third one? That is, how can we compute, the a21 element? In this case, these row will be multiplied with this and added together. Okay, so 5 into 1, 5 into 1 plus 2 into 2. Similarly, now this row will be multiplied with this column, so 5 into 5, okay, plus 2 into 1. Okay, so this is the matrix multiplication. You can see it is 1, it is 7. Okay, and this is 5 plus 3, it is 8, and this is 5 plus 4, it is 9, and this is 25 plus 2, 27. Okay, now another question is there. If I compute B cross A, we have computed A cross B and we have got this matrix. But if I compute B cross A, will it be equal to A cross B? Answer is not always. It means that it is not basically universally true. B cross A is not always equal to A cross B. Okay. Okay, so now I will give you another form of the matrix is also there. It is called transpose of a matrix. Transpose. Sorry. Okay, transpose of a matrix. It is the rows and columns will be just converted together like this. Suppose it is 1, 2, 3, 4, 6, 7. Okay, 8, 9. This is suppose 5. Now what is A transpose or AT? Okay, this is equal to, now what is the first row? 1 2 3. The first row will be converted to the first column of this matrix, that is 1 2 3. What is the second row of this matrix? 4 6 and 7. the second row of this matrix we will convert it to second column of this matrix. It will be 4, 6 and 7. Now what is the third row? 8, 9, 5. It will be 8, 9, 5, the third column of this matrix. So this is the transpose of A. Okay, it is very obvious. If I take A transpose whole transpose, it is means transpose of a transpose, of course we will be getting the original matrix again. Okay, so this is the transpose of a matrix. Okay, so now I am going to show you a programming, that is MATLAB programming, how you can represent matrix in MATLAB, and how you can do different operations like matrix addition, matrix multiplication, and find out the transpose of a matrix. Okay, so let us. Okay, so this is the MATLAB file. We already have opened a script file here. So let us, if you do not have the MATLAB, then you can use the online version of the MATLAB by using your email, official email ID. You can use the MATLAB. Okay, this MATLAB is free for 30 hours for 1 month. Okay, and the matrix, or if you from your institute also, you can also get the version of different versions of the MATLAB. Okay, from your institute. Okay, institute and institutional version, they have the subscription of MATLAB. You can also get there. So MATLAB, there are two cases. First of all, there is a command window. You can see here. A command window is here. There is this one. Basically, every matrix, that is, if I suppose 1 plus 1, the answer is 2. It is easily in command window. Directly you can put anything. Okay, directly you can put some addition, subtraction, matrix operations, multiplications, anything you can find it. But in command window you can put one operation. Okay, but if you are going to do some multiple operations, like you have to form a loop, or you have to form some other means a big program, then command window is not a suitable version. So for that case, you need to use this script file. Script file can be made here. You just go to new. Okay, and the script file, automatically it will be opened. You can see untitled script file, it will be opened here. Okay, remember that the matrix sorry, this file, it will only, you can run this file if you save this untitled script file with a file name. I already have a file name, matrix operations. I have already saved it. Okay, so now I am going to give you the operations of matrix. How can you represent a matrix in MATLAB? First of all, let me show you this. Okay, first let me clear the screen. CLC, it will clear the screen every time you run the operation. That is, every time you run the program, it will clear the command window. Next, clear, it will clear the memory. That is, if you put some variable values, it will clear command, it will clear the memory of that particular variable every time you run the program. Okay. So now how can you represent the matrix? It is very simple. Let us suppose first think about a name of the matrix. Let us suppose capital A. Okay, now capital A is equal to, we have to just put a third bracket first, and let us suppose the matrix is 2 cross 2 matrix. Okay, with the first and second row, and like this 1, 2. Okay, so just put a space. This is the first row. In the first row, 1 and 2, only these two elements, 1 and 2. And how can you put the second row? Just semicolon, put a semicolon, 3 space 4. Okay, and you can close the bracket and then terminate this one. So the matrix A is created. Okay, now you can see in command window we can visualize this matrix. To visualize DISP, this is called the display operation. Okay, DISPA. Just if you put this one and if I put the enter, okay, and I run, you can see here the run operation. Just run here. You see in command window the matrix is already generated. 1, 2, 3, 4. Okay, so this is the script file. You have to run this file. Okay, you have to run this file. Now in command window also I can easily directly I can put this matrix like this. Suppose 1, 2, 4, 5. You can see directly this matrix is formed, but we cannot put a particular means for suppose matrix addition or multiplication or transpose or different kinds of operations in a single file. If we want to put, then command window is not a suitable file, because it will only just you enter it and it will only they execute the exact just whatever you have written. Only one time it will execute. Okay. Okay, now let us suppose here. So I'm deleting the display here. So let me enlarge this matrix like 3 cross 3. Okay, suppose 1, 2, 3. Second row it is 3, 4, suppose 5, and third row it is suppose 6, 9, 8. Okay, and let us suppose another matrix B. This is equal to 1, 3, 5, 2, 2, 3, and let us suppose 1, 6, 8. So we have made two matrices here. Now we need to add it. Simply A plus B. Let us suppose add is equal to A plus B. Okay, and we need to of course we need to display this. So DISP. Which one we need to display? Add, because add equal to A plus B. Okay, or you can simply put here DISP A plus B. This also will work. Okay, run the program. You can see here. Okay, so this is the matrix addition. You can see, you can also check this one the same. Similarly, we can subtract this matrix A minus B. Okay, and run the program. Look, the subtraction is generated. Okay, now we can multiply this one. Okay, let me just omit this statement. We can multiply. How can you? Just A star B. Display. Look, this is the matrix multiplication. It's taking a little bit time. Okay, so matrix multiplication is already formed here. So this is how it is. Very simple. Very simple means matrix representation in MATLAB is very simple. Now how can you find the transpose? Okay, now transpose of a matrix, it will obviously transpose operation, it will operate on a single matrix. Okay, so let us suppose transpose of A. So DISP, just we need to put A dash like this. Okay, and then look, this becomes the transpose of A. And also we can display the transpose of B dash. Look, this is the transpose of A and this is the transpose of B. So two matrices can be displayed like this. Okay, transpose of two matrices. If I want to add these two transpose matrix, okay, then just simply DISP, okay, A dash plus B dash, and run this. You can see this one is the addition, and addition of the transpose of these two matrices. Okay, I think now it is now very much clear how can you represent a matrix in MATLAB. Okay, now we are going to our next step. Okay, so which is important for many competitive examinations, and also which is important for our mm, means engineering mathematics applications, which is called the rank of a matrix. Okay, so first of all, I need to say, rank of a matrix, there are different methods are there to find the rank of a matrix. So first method, which is the basic method, that is according to the definition of a rank of a matrix. So actually, rank of a matrix of m cross n, we can find the rank of any dimensional matrix. So let us consider, we need to use rank. Okay, let us consider capital A is a matrix m cross n. There is the dimension is m cross n, m number of rows and n number of columns are there. Okay, so the rank of capital A is defined as the greatest positive integer r, the greatest positive integer r, okay, such that A has at least one non-zero minor of order r. Okay, so how can you represent it, or how can you, if I give you an example, then it will be clear to you. Let us consider capital A is equal to 1 0 3 4 minus 1 5 and 2 0 6. Okay, so let me find what is the rank of a matrix by using the definition what I gave you. Okay, so definition according to the rank, first of all we need to find out the determinant of A, the determinant of A, okay, or date of A. Okay, so if you find the determinant, I think you already know how to find out the determinant. Okay, so still I am expanding the determinant here. So 1 into minus 1 into 6, okay, minus 0 into 5, next one is minus 0 into whatever the multiplication is 0, of course it will be 0, still I am just giving you the example. So 4 into 6 minus, okay, 5 into 2 and plus 3 into 4 into 0, okay, minus, it will be plus actually. Still I'm giving minus 1 into 2. So, okay, so you can find this matrix, and after finding this sorry determinant, and after calculating this one, you can find the determinant, it becomes 0 actually. Okay, so now this determinant of A, it is actually determinant of 3 cross 3, that is the determinant of A, and A is a 3 cross 3 matrix. So the entire determinant of the entire matrix, it becomes 0. If it becomes a 0, okay, then we need to go for the, so we can conclude that the rank of this matrix, rank of A, must not be equal to 3. Okay, again I am giving you, if you find the determinant, okay, if you find the determinant of the whole matrix and found that the determinant of the whole matrix is equal to 0, then we can of course conclude that the rank of this matrix not equal to 3. Okay, if the 3 cross 3 determinant it becomes 0, then we need to go for the first minor determinant, that is the second order minor determinant. Minor, that is second order minor means 1 0 4 minus 1, there is this particular minor. So determinant of 1 0 4 minus 1, and we need to check that this is also 0 or not. Okay, you can see this is not equal to 0. Okay, since the second order minor is not equal to 0, then we will say the rank is 2. Okay, so basically concept is it is quite I think not clear to you. Let me explain it again. First we need to find the determinant of the entire matrix. If the entire matrix, that is 3 cross 3 determinant, is equal to 0, then we say the rank of A is not 3 but less than 3. Okay, now the question is, if the determinant of A, that is 3 cross 3, the entire determinant, it is also not equal to 0, in this case what will happen? Then in this case we can say yes, the rank is 3. If the first, that is the first determinant of the entire matrix, it becomes non-zero, then we will say the rank is 3. But if it is 0, then we will say it is not equal to 3, it is less than 3. Now since it is less than 3, that is why we need to check the second order minor also. This is the second order minor, 104 minus 1. We need to check the determinant. If it is not equal to 0, then we can say the rank is 2. But still, if this is also equal to 0, then we say the rank is less than 2. Okay, and if it is less than 2, then we have to see this one, this element 1 not equal to 0, then the rank is 1. Okay, so this method is quite, it is a not that much easy method to find out, because for non-square matrix, okay, too many minors will be there and you need to check, so that will be very difficult. So that is why there is another method exists, which is called the method of matrix elementary operations. Elementary operations. Okay, so elementary operations of a matrix. So I'm giving a first going to give you what is an elementary operation of a matrix. Okay, so elementary operations operation on a matrix, it is actually you can see a very simple example. If I give you, suppose 2x plus 3y, okay, is equal to 2, and x minus y is equal to 1. Solve these two equations. Can you solve it? Yes, it is very easy to solve. Everybody can say that yes, this is easy to solve. Okay, now there are many methods to solve, but one method is deletion of variables. If you remember, okay, that is, I can multiply, look at this, this is equation number 1 and this is equation number 2. I can multiply equation 2 with 3 and then add them. Okay, that is equation 2 is multiplied by 3 and then plus equation number 1. If I do this, what will happen? So equation 2 is multiplied by 3, it means it becomes 3x minus 3y is equal to 3, and 1 equation is 2x 3y is equal to 2, and if I then add these two, add plus plus plus, so what will happen? 3 plus 2, 5x, and plus 3y minus 3y, it will be nullified and it is 3 plus 2, 5. So it means x equal to 1. We can easily solve it. So ultimately what we are doing in this equation, we are eliminating some variables. Either we are eliminating x or we can eliminate y. So exactly elementary operations on matrix is actually the deletion of these elements, some elements of the matrix, by using some matrix elementary operations. Exactly, we will do the same method, we will follow the same method what we have done here in this equation to eliminate one variable. Okay, so let us give you one example of this. Let me erase this one first. Okay, so let me give you one example. Elementary operation, row operation. Okay, try for a big matrix. 2 0 4 2 3 2 6 5 5 2 10 7 and 0 3 2 5. This is the matrix. Okay, so according to my suggestion, it is what I suggest. So before starting the elementary operation, you need to check something, that is what is our duty. Our duty, we are going to operate this matrix on elementary according to elementary row operations only. Okay, I'm not going for column operation. Column operation is also there, but I am going to show you the row operation only. Okay, after the row operation, we can easily identify the rank of the matrix. We can easily solve the matrix also, that is solve a system of linear equations also. Okay, so let me first give you some of the tricks here. First element, that is the first row and first column, this element, this one. Okay, better to make it. Yes, in some other books you can find direct operations, but what my suggestion is to make this particular element as 1. And how to do this? Simply, you can do it by 1 by 2 into R1. Okay, because this is R1, this is R2, this is R3, this is R4. 4 rows are there. So I multiply 1 by 2 or divide R1 by 2. So what will happen now? Of course, this will be, that is this 2 will be 1 because I divided by 2. Now 0 divided by 2, now what is the second element? 0 divided by 2, it is 0. Third one, 4 divided by 2, this becomes 2. Fourth one, 2 divided by 2, 1. Okay, again I am explaining. Always our target is to make the first row and first column element, that is the first most element, it we have to just make it as 1 anyhow. So if it is 2, just divide by 2, it will become 1. So just a 1 by 2 into R1. But remember, 1 by 2 into R1 means R1 is the entire row. So you have to multiply half with all elements of the first row. So that is why it becomes, this 4 becomes 2 and this 2 becomes 1. Okay, and all the other elements of all the other rows will be remain same. 3 2 6 5 5 2 10 7 0 3 2 5. Okay, our next target. Now what is our next target? Our next target is this and this, these three elements. Just after taking the first element as 1, okay, after making the first element as 1, then just the below elements, that is the first row first column elements, below the first row and first column element, we have to make this and these three elements as 0. Okay, look at the last element, this is already 0, so we don't have to make anything. But second row first element of the second row and the first element of the third row, we have to make them 0. There is this one and this one. How can you make it? Look at this operation what I am doing here. Okay, this is 3. So if I do like this, 3 minus 3 into 1, that is, look at this is 1, right? So 3 minus 3 is equal to 0. So the element which will be changed, that is, this element will be changed. This element is on row 2. So we will write here R2 minus 3 into R1. Now look, after this operation, what will happen? Okay, remember that we will only change this row 2. Okay, we will only change row 2. So the row which will be changed, we will put it first, that is R2 minus 3 into R1. Why I am doing it minus 3 into R1? Now you can identify this one. First row will be remain same, 1 0 2 1. Look, R2 means all elements of row 2. So what is the first element of row 2? 3. So 3 minus 3 into R1. What is the first element of R1? 1. So 3 into 1. So it becomes 0. So this becomes 0. Okay, so we made it. We made this element, that is the second row first element, as 0. But according to this operation, it must be operated on all the elements of row 2. So what will be the second, what will be the this element? This element will be 2 minus 3 into 0. So it becomes 2 itself. 2. Right? Next one, how this element will be changed? This is 6, that is R2. Okay, 6 minus 3 into 2. This is also 0. And how this element will be changed? This is 5 minus, okay, 5 minus 3 into 1. Okay, so 5 minus 3, it becomes 2. 2. Okay, so can you tell me what will be the operation for the, now we need to make this element, this 5, this element as 0. Okay, with respect to the first row. Okay, remember, all these three elements, just after this, all these three elements will be 0 with respect to the first row. So how can you make this element 0 with respect to the first row? Now we will do this operation, R3, this is row 3. So R3 minus, so what is this? This is 5 into R1. Okay, now this element will become 0. You can simply calculate it. R3 means first element of R3 is 5, minus 5 into 5, 1. So 5 minus 5, it becomes 0. You can easily calculate. Okay, what is the second element? Second element is 2. So 2 minus, okay, so it is 0, 5 into 0, so it is 2. Third element is 10, so 10 minus 5 into 2, it is 10. 10 minus 10, this is also 0. Fourth element, it is 7. 7 minus 5 into 7, sorry, 7 minus 5 into 1, so for 7 minus 5, it is 2. So this is 2. Okay, now the last element, this is already 0, so we don't have to make anything. It is already 0. 0, 3, 2, 5. So first operation is already met. Now what is our next target? Our next target is to make this element as 1 again. There is a diagonal. We are actually talking about the diagonal elements here. Okay, so first element is 1. Now this element we need to make it 1, and after making it 1, this and this will be 0 with respect to row 2. Okay, so first let me convert this one as 1. What is the operation here? How can you do this? So this 2 is actually situated on row 2. So half into row 2, half into R2. Okay, so this 2 becomes 1. So 1, 0, 2, 1, 0, 1, 0, 1. Okay, enter this half into row 2 means half will be multiplied with entire elements, all the elements of row 2. Third element is remain same, 0, 2, 0, 2. This is 0, 3, 2, 5. All other elements are same. Okay, next with respect to this element, we need to make this one and this one as 0. Now how can you make it, and what will be the operation? Okay, so what will be the operation? Okay, just I'm giving you some time to think, then I will be writing here. Okay, so did you think what will be the operation here to make this one and this one as 0 with respect to row 2? Okay, the row 2, this is row 2, this is row 3, this is row 4. Look, the formula is very simple. Okay, and subtracting, look, this is 2, right, and this is 1. So how can I do this? We are changing. Which row is going to be changed now? This element is going to be changed. This element is on row 3. So we will write here R3 first. R3. Now this is 1 minus, what is the element here? 2. So 2 into R2. Okay. Similarly, how can you make this element as 0 with respect to R2? R3, this element is situated on R3. Sorry, R4. R4 minus 3 into R2. Look, the formula is very simple. After making 1, look the elements only. This is 2. So R3 minus 2 into R2. This is 3. So R4 minus 3 into R2. Okay. Then you can give the first row is first row. No change. 2, 1. Second row also no change. 0. Third row will be changed. This is 0. Now this becomes 0. You can see R3 minus 2 into R1. So R3, this is 2 minus 2 into 1. So this becomes 0. Now 0 minus 0, this is 0. 2. Now this one. 2, 2 minus 2 into 1, 0. Okay, now what is the last row? 0. Now this is also 0 because this is 3. So 3 minus 3 into 1, this is 0. Now this is 2 and 0. So 2 minus 3 into 0, it becomes 2 only. Now last one, this is 5. So 5 minus 3 into 1, this is equal to 2. So this is 2. Okay, so now you can see, now this becomes this and this. Okay, now I told you diagonal elements, make the diagonal elements as 1, but you can see these diagonal elements after this operation, what will happen? After of this operation, these diagonal elements become 0. Now what will you do in this case? But the next diagonal element, it is 2. This is also 2. This is also 2. Okay. Simply what we can do, we can interchange these two rows. We can interchange these two rows. How can we interchange it? Just row 3 and row 4 will be interchanged. Sorry. Let me erase this one. So row 3, 4. Row 3, 4 means we will interchange row 3 and row 4 so that this element becomes a number other than 0. Okay, so what will happen here? So it is 1, 0, 2, 1. It is 0, 1, 0, 1. That is 0, 0, 2, 2. That is 0, 0, 0, 0. Now look at this. Now this becomes very, you can see these diagonal elements, now it becomes 2. Okay, now what we will do? Again, we need to make it 1. And what is the operations here? Operation is 1 by 2 into R3. So 1 by 2 into R3. Okay, so 1 by 2 into R3. So it becomes now all other, now only this row will be changed. So 1, 0, 2, 1 is 0, 1, 0, 1. It is 0, 0, 1, 1. Both will be multiplied with half and half. 0, 0, 0, 0. Okay, now what will happen? The last one, you can see, now this becomes 1. Now after that, is it 0? Yes, this is already 0. Now we don't have to make anything because the last row, that this element, it is already 0. Okay, so now this is called elementary row operation. So what is the structure? Now look at the structure of this matrix. Okay, it's very interesting. Look at this structure. I am, just let me, yes. Look at the structure. These three, that is just below the diagonal elements, all the elements becomes 0. This is our target. Okay, this is our target, to make the matrix in such a way, just below the diagonal elements, all elements will become 0. Okay, so this is the final matrix. After this matrix, we can easily find out the rank of the matrix. Okay, now after this stage, how can you find the rank of the matrix? The number of non-zero rows. Now what is non-zero row? Non-zero row, it becomes any row, any element, if any row has all elements as 0, then we will say that is a 0 row. Otherwise it is called a non-zero row. So look at the last matrix. This is row 1, this is row 2, this is row 3, and this is row 4. Okay, so which row has all elements as 0? Row 4 has all elements as 0. So we will say row 4 is a 0 row. And all other rows, you can see no elements. Each and every row, at least one element is there which is non-zero. So it means that how many non-zero rows are there? 3 non-zero rows and 1 zero row. Understood? So the number of non-zero row, the total number of non-zero row will define the rank of the matrix. Okay, so what is the rank of matrix? How many non-zero rows are there? 3 non-zero rows. So the rank of the matrix is equal to 3 for this particular matrix. I think all of you have understood. Is there any other shortcut method? Yes, no, there is no other shortcut. There is no other shortcut. If yes, in GATE exam or if any other competitive exam, the size of the matrix may be lower. I have given you the bigger matrix, but size of the matrix it maximum will be 3 cross 3, not more than that. Okay, and rank of the matrix, some other tricky questions will also be there for rank of the matrix in any competitive examinations. So you don't have to calculate all of these things. Okay, so we are at the end of our today's lecture. So now I will give you how to find out the rank of the matrix in MATLAB. Okay, so in MATLAB, let me go to the yes. So you can see here two matrices are given. Okay, two matrices are given. So I have this one. Hit command line also. Yes, A and B two matrices. So I am giving you the just rank of matrix A. Okay, what is the command here to find out the rank of the matrix? Just simply rank. Okay, DI is with the rank of A. Let us consider another variable, capital R, which defines the rank of capital A. Okay, and let us display capital R. Now run this program. You can see what is the rank. 3 is the rank of the matrix. Okay. Similarly, what is the rank of B? Now simply you can display the rank of B. Rank of B is also 3 here. Okay. So both rank of A and rank of B both are 3 here. So this is very simple to identify what is the rank of matrix in MATLAB. Okay, the command is only rank is the command, rank of A or rank B, like this. And you can use the DISP operation, that is DISP command, to display the rank of the matrix. Okay, so this is all for today. Okay, so thank you for attending the lecture, and if you have any query, then you can ask in the next lecture, or you can follow us our page, follow the page, our social media page, and also you can follow the website www.innovaworld.info, and you can also put the queries here.